Latest eruption of Mount Etna. Volcano, Europe's most active volcano, unleashes a new spectacular eruption. Mount Etna has awakened once again. Towering over the eastern coast of Sicily, Italy, Mount Etna is no stranger to volcanic activity. Standing at more than 3,300 meters above sea level, it is Europe's highest and most active volcano, erupting dozens of times every decade. Yet, every new eruption reminds scientists and residents alike that Etna remains one of the most dynamic and unpredictable volcanoes on Earth. In early July 2026, after several days of increasing volcanic tremor and growing seismic unrest beneath the summit, Etna entered a powerful new eruptive phase. Instruments operated by Italy's National Institute of Geophysics and Volcanology, INGV, detected a sharp rise in volcanic tremor, indicating that magma was rapidly moving upward through the volcano's underground plumbing system. Shortly afterward, spectacular Strombolian explosions began bursting from the summit craters, sending incandescent lava hundreds of meters into the air, while dense columns of volcanic ash climbed thousands of meters above Sicily. The eruption developed from a fracture that opened near the northeast crater at an elevation of roughly 3,000 meters. From this newly formed vent, lava slowly spilled down the steep volcanic slopes toward the Valle del Leone, one of Etna's most active volcanic valleys. Although the lava advanced steadily, volcanologists noted that its relatively high viscosity slowed its movement, reducing the immediate threat to populated areas while creating spectacular rivers of glowing molten rock visible for many kilometers during the night. As darkness fell over Sicily, the mountain transformed into an extraordinary natural spectacle. Brilliant orange lava fountains illuminated the summit, while countless glowing volcanic bombs arced through the sky before crashing back onto the crater rim. Thick clouds of volcanic gas mixed with ash rose high into the atmosphere, creating a towering eruption column visible across eastern Sicily. Satellite observations and ground-based monitoring stations confirmed that volcanic ash was drifting southward with the prevailing winds. Because volcanic ash poses a serious hazard to aircraft engines, aviation authorities quickly raised the aviation color code to red, the highest warning level for aviation. Air traffic controllers immediately began rerouting aircraft to ensure passenger safety, while emergency officials closely tracked the movement of the ash cloud. The eruption soon began affecting transportation across the island. Catania Fontanarossa Airport, Sicily's busiest airport and the closest major airport to Mount Etna, experienced major disruptions. Incoming flights were diverted to Palermo, while numerous departures were delayed or canceled. In total, dozens of commercial flights were affected as volcanic ash reduced visibility and threatened aircraft operations. Even the airspace over the nearby Sigonella Air Base was temporarily closed because of the volcanic plume. Thousands of travelers found themselves stranded as airlines worked to reorganize schedules and reroute passengers. Fortunately, despite the dramatic appearance of the eruption, authorities reported no fatalities or major structural damage. Most of the lava remained confined to the volcano's upper slopes and natural lava channels, far from towns and villages surrounding the mountain. Nevertheless, emergency services remained on high alert because Mount Etna's behavior can change rapidly, sometimes within only a few hours. Mount Etna's frequent eruptions are the result of an exceptionally complex geological setting. The volcano sits near the boundary where the African plate slowly pushes beneath the Eurasian plate. This ongoing tectonic interaction generates fractures deep beneath Sicily, allowing magma from Earth's mantle to rise toward the surface. Unlike many volcanoes that erupt after decades of dormancy, Etna possesses an almost continuous magma supply, making frequent eruptions a defining characteristic of its behavior rather than an unusual event. What makes Etna especially fascinating to scientists is that no two eruptions are exactly alike. Recent geological research has revealed that even eruptions of similar size can originate from completely different underground pathways. By analyzing ancient volcanic deposits, researchers discovered that magma can ascend through separate plumbing systems beneath the volcano, with different gas contents, ascent speeds, and storage depths. This means that forecasting Etna's future behavior remains an enormous scientific challenge, even with one of the world's most advanced volcano monitoring networks. Today, Mount Etna is monitored around the clock using hundreds of scientific instruments. Highly sensitive seismometers detect tiny earthquakes generated as magma fractures surrounding rock. GPS receivers measure ground deformation with millimeter precision, revealing when the volcano begins to inflate as magma accumulates underground. Thermal cameras continuously observe the summit craters, while satellites track sulfur dioxide emissions and thermal anomalies from space. Together, these technologies provide scientists with a remarkably detailed picture of the volcano's internal activity, often allowing them to recognize signs of an eruption before lava reaches the surface.